All right, everybody. This video right here, just another example. I just want to get more practice with Newton's law of cooling. All right, so we're just, like I said, this is the only thing we're going to do in this video. I'm going to have another video for you as well. I'm going to make a new one. That's a little bit different. I'll try to give you guys a little bit of an activity to do next time. But today, what you guys are going to do is watch this video, just one quick video, and then you'll have the rest of the class to work on an assignment. All right, so here goes. Let's get into it so we can wrap it up early here. So it says a cup of coffee has cooled from 92 degrees, and this is all in Celsius, to 50 degrees Celsius after 12 minutes in a room at 22 degrees Celsius. So that's going to be the temperature of your environment, or the temperature of the medium, T sub m. How long will the cup take to cool to 30 degrees Celsius? All right, so if you remember, we did one example last time, and what you need to do is come up with two equations. All right, you need a big picture equation to answer the entire thing, the main concept, but you're also going to need an equation to figure out what K is. All right, you need to find K before you can find your little t here, because you're going to have two variables in the big picture equation, K and T. All right, so tell you what, let me write the big picture equation. Yeah, I'll write on the other one right here. Okay. And by the way, rewind this if you haven't written that down already. I should rewind it and make sure everybody has that written down. So here we go. I'm going to do the big picture equation. It's kind of light. Hopefully you guys can see that. Yeah, I think that's good. All right, so the big picture equation, let's try to walk through here. And I went ahead and wrote Newton's law of cooling on the last one. I'll go ahead and write it again. So it's T of T, it's temperature with respect to time, is equal to the temperature of the medium plus the initial temperature minus the temperature of the medium times e to the negative k t. All right, so I'm going to start filling this in. Now, I'm going to kind of run into a place where I get stuck. All right, so when we do that, then I'll try to come up with another equation to figure out what K is. All right, so here goes. The first thing I want to do is fill in my temperature with respect to time. So if you read the problem again, make sure you guys read this. I'll read the whole thing again. It says a cup of coffee has cooled from 92 degrees to 50 degrees after 12 minutes in a room at 22 degrees Celsius. So big picture, it says how long will the cup take to cool to 30 degrees Celsius? So we want this temperature after a certain amount of time to be 30. So I'm going to need to fill 30 in for T of T. All right, hopefully that makes sense. Now the temperature of the medium is just the temperature of the room. In this case, it's the room temperature. So it says the room is 22 degrees Celsius. So this would be 22 plus the initial temperature, which is, I think it says it begins at 92 degrees. It starts from 92. And then minus the temperature of the medium, which is still 22, times e to the negative kt. So we don't know what this constant is. That constant changes depending on what substance you have. So like I was mentioning yesterday, a cup of coffee cools differently than, for example, use an egg. Or what I like to do is a dead body. Use dead bodies. Not me personally, but yeah, just like... Anyways, moving on. So this is going to change, all right? So that's what we're going to have to figure out. We're going to have to figure out what that K is, because again, we're talking about this cup of coffee. And then, like I said, big picture, we're trying to figure out how long it takes for it to get down to 30 degrees. So that's the idea. So this is where we're kind of stuck. You guys notice we have two variables, K and T. I don't think I really pointed this out. This E is the number E. It's not a variable. It's the number E, 2.71 ... that irrational number, Euler's number. So I think I might have glossed over that yesterday. Hopefully you guys know what I'm talking about. So here we go. I'm going to come back to this, but let me try to come up with the K equation here. So I'm going to erase this problem. I've got it written down so I don't forget it here. Hopefully you guys do as well. All right, so here goes. K equation. Here you have it. So the K equation, I need to use the same thing, Newton's law of cooling. So T of T is going to equal my temperature of the medium plus the initial temperature minus the temperature of the medium times e to the negative k T. All right, so that's the formula. And we just need to start filling some stuff in. Well, the K equation, what you need to fill in for that is the extra information that we haven't used yet. So the sentence or phrase that says it cools from 92 degrees to 50 degrees after 12 minutes. So it gives you a time. We can plug in 12 in for your time. We want K to be the only variable. Okay, so we're going to plug 12 in for our time. There's going to be a different T of T. So the temperature after 12 minutes, it wants it to be 50. So we're going to fill 50 in there. So that's the temperature after 12 minutes. And the temperature of the medium doesn't change. The room temperature is 22 plus the initial temperature, which was is still started at 92, I believe. Let me just make sure. Yeah, that's 92. Minus the temperature of the medium is 22 times e to the negative k T. And instead of negative kt, let me rewrite that, is negative 12k, because didn't we say our time in minutes is 12? And by the way, if our time is in minutes here, it's going to be, my answer is going to end up being in minutes as well. So, all right, so now it's just solving. We've done a problem very similar to this yesterday. We're just going to keep getting practice with this. So here we go. Let's try to solve this equation. So we still have 50 is equal to 22. I'm going to simplify here. 92 minus 22 is 70. E to the negative 12k. Okay, let's keep going. I want to try to get k by itself. I want to isolate the variable, so I got a lot of stuff to take care of first. The first thing I'm going to do is subtract 22 from both sides. 22's cancel over here, so we're left with 28 on the left side. That's equal to 70 times e to the negative 12k. All right. So here goes. Let's keep going. The next thing I want to do is, I've got this 70 times something. That's easy to take care of. We need to divide by 70 to undo that. So it's 28 divided by 70. Let me type that and get a decimal. Oh, that's just 0.4. Yeah, I should have known that. 0.4 is equal to e to the negative 12k. So this is what we've been working on, all right? This is why, this is the whole point of this section, is to solve exponential and logarithmic equations. Well, right now this is an exponential equation. So how do we undo an exponential equation? How can I move this exponent down? Well, I can't move it down yet. What do I have to do to both sides before I can move it down? And the answer is take a logarithm of both sides. Now the one I usually use is ln, especially in this case because we're dealing with e. And I know we're going to have ln of e eventually, and that makes it pretty easy. But you could use log base 10 if you wanted to. You could do log base 10 on both sides. I would choose one of those, though, because your calculator does those easily. All right. There's a button already programmed in for them. So either pick ln or log base 10 on both sides. I'm going to do ln. All right, so we got ln of 0.4 is equal to ln of e to the negative 12k. All right, so we're getting somewhere. Now that I've done that, I'll do the rest of my work over here. Go around the camera here. So now that I've done that, let me just rewrite this. ln of 0.4, that's going to equal, I'm allowed to bring this exponent down. All right, that's the power rule of logarithms. Okay, so it's going to be negative 12k down here, and it's going to be times ln of e. Now, if you remember yesterday, I didn't write ln of e because what is ln of e? The answer is 1. So I don't really need to write times ln of e. I could if I wanted to, and then simplify from there, but I'll just leave it like that. And then I'm going to divide by negative 12 to get k by itself. And so just type that into the calculator. Give me a second. I'll do that on mine. It is going to be ln of 0.4. Make sure you end the parentheses. And then divided by negative 12. And it's giving me 0.76 sorry, excuse me, 0.0764. Now remember, I like to go 4 decimal places because we want to be as precise as possible. All right, so let's go 4 decimal places there. All right, so that's our K. Don't forget that number. Well, you should have it written down. I'll come back to it if I forget it. But all right, so here goes. So we're going to take that K and we're going to plug it back into the big picture equation. Now, like I mentioned yesterday, you already have, sorry guys, I'm struggling here, getting that fixed. Come on. There we go. So you already have a framework of how to solve this equation. We've already done it pretty much. I mean, just we have some different numbers. It's the same process though. So I'm going to simplify and I'm going to plug in what K is at the same time. So it's going to be 30 is equal to 22 plus 70. Remember, 92 minus 22 is 70. E to the negative 0.076, I think it was 4 T. So we found K. I'm just double checking here behind the board. Yes. So we found K. We plugged it back in. Hey, look, we only have one more variable, and so we should be able to solve for it. So it's the same process. I'm going to subtract 22 from both sides. So this gives me 8 is equal to 70 times e to the negative 0.0764 t. Need my calculator here. Then I want to get t by itself, so I have to undo this multiplication by 70 by dividing by 70. So 8 divided by 70 is, and let's go 4 decimal places, so it's 0.1143. And that's equal to e to the negative 0.0764 t. Okay, now we're to the point where we need to try to move that exponent down. Well, again, how do we do that? Well, in order to move that exponent down, I have to have a logarithm of both sides. So I have to take ln of both sides. So it's going to be ln of this number right here, 0.1143, is equal to ln of e to the negative 0.0764 t. Okay, now using the power rule, I'm allowed to take this exponent and move it to the front. Move it to, rewrite it as a coefficient. So that's what I'm going to do over here. So it's going to be ln of 0.1143 is equal to negative 0.0764 t. And then, again, it would be times ln of e, but I can just drop that because that's just 1. And so I just need to divide both sides by negative 0.0764. Okay, so let me do that. It's ln of 0.1143 divided by negative 0.0764. Enter. I got 28 minutes. So 28 minutes, let's say 28.4 minutes. I'm not going to convert it to seconds. Somewhere about 28 minutes is my answer, but and that'd be it. Circle that. So that's how long it would take a almost boiling hot cup of coffee, because 92 degrees is almost boiling, 100 degrees is boiling in Celsius. That's how long it would take a 92 degrees Celsius cup of coffee. That's how long it would take to cool to get to 22 degrees. So that's about room temperature. So it sounds pretty reasonable. If it's almost boiling, it might take that long for it to cool to get to room temperature. So, all right, that is it for this video. Like I said, next video I'll have for you, it will kind of be an introduction to an activity that I want you guys to do. It's going to be similar. It's going to be another Newton's Law of Cooling thing. But, yeah, I'll stop the video right here, and you guys can work on an assignment just to practice this. See you guys.